Hello, here I am in my summertime Waterloo Engineering purple t-shirt. All right, what are we going to talk about today? We got two quick things, sort of administrative things to go over for you. Bit longer, quite a bit longer on talking about the basic nature of search engine architecture. Let's give you a high level view of what's going on. And basically our goal is by the end of the course is to have built all the parts for such a system, at least simplified versions of these parts, so that we understand how the search engine really works. And then I'll give you some verbal instructions and guidance on stuff that you need to know to get homework 1 done, in addition to what you will see in the printed version of the instructions. So it'll be, those two will complement each other. All right, so what do I need to tell you now about, first thing being GitHub? Well, the first thing about GitHub is we're going to distribute a form for you. And a goal of this is we need to basically collect your GitHub username. This is handy for us. What we will be doing is setting up a GitHub classroom. Through the GitHub classroom, it will allow you to go in there, request a repository to be created for you. And then within that repository, you'll work and then submit your work to GitHub. And this is the way that we'll actually be able to collect the code portion of your work. The problem side, if you're going to answer problems and stuff, that'll be work that we will have you submit via CrowdMark. And so we need to separate those two parts in the assignment, CrowdMark and GitHub. So again, GitHub for your code and CrowdMark for a separate part. All right, so what's next? Well, the next thing is what we're going to work with in this course is data from Trek. And Trek is the text retrieval conference. It's about 30 years old now. And it is run by the National Institute of Standards and Technology outside of Washington, D.C. It's actually in Gaithersburg, Maryland. So this is an annual conference. Information retrieval researchers participate in it. We hold what we call separate tracks. Each track investigates different aspects. For example, right now, myself and some collaborators, we co-organize a track called the Health Misinformation Track. And this track allows researchers worldwide to investigate issues of health-related misinformation that we might find in document collection, and how search engines can better serve people who are looking for health misinformation so that they do not actually get the misinformation, which then could lead to very bad decisions regarding their health if they relied upon that. That's an example. Now, this conference, as I said, has gone on for nearly 30 years. Now I think it is its 30th anniversary this year. And so over that time, one of the things it does is it produces test collections. Test collections consist of a set of documents as well as topics, search topics, and relevance assessments. So we're going to be using a small little subset of that. Now, one of the issues present in this is that the data, which is, it's quite old, but it is still under copyright. It still requires special permission to use it. And as such, for me to share it with you, I need you to agree to the rules that pertains to it. So the data is copyrighted. So the big thing is you need besides that? But it's largely because of that it's been licensed for use in for research, that there's restrictions on it, and I need you to be able to follow those restrictions. Okay, so you may only use the data. These are the documents for this course. Okay, so your usage is limited in that regard. Certainly, it's copyrighted material, so you may not, absolutely not, post or distribute it. All right. When you're done with it at the end of the term, you must delete it. So once we've completed the course, go in there and delete it. And it will take up a small chunk of space, so you'll want to do this anyway. And here's the big gotcha. If you violate the rules, this will be academic misconduct, as in you're in trouble and you're going to lose lots of points, and it will result in course failure. So if I find you in violation of these, I will pursue it with the associate dean, and the highest grade we're going to give you is a 46. Now, you're like, oh, well, simply put, there is a form in Learn, and you can find it under the course administration, and there's some brief instructions. You'll find the form and how to fill it out. It's a PDF document, so use whatever mechanisms you have for filling out and signing these documents. Read it carefully. You'll see that it says this sort of stuff, but there's also other restrictions on it. And sign it, and then you upload it to the Learn Dropbox. And then once you have done that and we have verified that you've actually signed it and agreed to this agreement, then we'll be able to release the data to you for use. All right, and it consists of material from the Los Angeles Times, dating, it's quite old, but it's their articles, not ours. Probably somewhere between 120 and 130,000 newspaper articles. All right, so be sure to go, you can go and do that now. That's in Learn. All right. Now, on to the more enjoyable matters. What is sort of the notions of building a search engine? All right. So there's a set of steps that we follow. And while I'll present this as, oh, we do this, and we do this, we do this, the reality is this is in a modern web search engine. This is a continual thing going on because there's continually new documents coming in. So it's a non-ending process with a commercial search engine. But for our sense, we can kind of think of it with these stages. The first step is to gather the documents. We need to bring them all into the computing system that we're going to be using so that they're there. If you are a web search engine, this means you use a web crawler. The nature of the web crawler is, you start it with some seed websites, web pages out there. It goes and it fetches one of those pages, brings it in, and then it reads it. And it says, oh, okay, it has these following links. And what it does is it, in a very much a breadth first fashion, it then goes and fetches those links, which those pages have links, and it fetches those, and so on and so forth. Don't go write your own web crawler. There are very good open source versions of web crawlers out there if you ever wanted to use one. But I advise you to not dive into the world of web crawling. Especially not unless you want people to start trying to shut down your web connection, your internet connection. You don't want to hear complaints and so forth. There's a lot of issues involved in running these crawlers. They can, if they're not run properly, they can be extremely resource intensive on a website and effectively do a denial of service attack on them. Website owners don't like you to do that at all. One of my favorite stories about this was when I was at the University of Waterloo. One of the co-authors of the search engines textbook, he's a fellow graduate student, and said, yeah, why don't we got this nice big machine server, let's run a web crawler and let's see how many pages we can get. Like, why don't we just do a little bit on our own? That sounds like a great idea. And so he set it up and he started it running, and I think took off for the weekend. Somewhere along the lines, all hell broke loose when the university wanted to know who was doing this. Why did the university get so upset? Well, one, a vast amount of traffic was being funneled through the department, and they wanted to know what was happening there. But the other thing was that because it was run from within the university network, it ended up then going eventually to the web page of the university library. And then from the university library and other sources, it ended up visiting journals. And since the journals knew that we were coming from the university, it said, oh, you have permission to download our articles. And so it started fetching and downloading all the PDFs for these journals. And then the servers for those journals said, wait a second, someone is stealing all of our material. Oh my goodness gracious, it's the university. And then they called the university and like, we are going to cancel your contracts. We're going to, sue you, blah, blah, blah. And the university said, we're not doing it. And eventually they find out that it's a graduate student. So look, don't go start crawling things. It's something that needs to be taken very seriously, because you end up utilizing resources and resources of other people. And it has to be done very carefully and wisely. I don't have you do it in this course for those reasons. Otherwise, it would be a lot of fun. But it brings us more issues than you can envision. So you could also have a crawler that might crawl inside a company's intranet. But you could even be talking about search engines for your own email. So how are you going to collect all your separate email documents? What's the connection to the email system to do that? Or, if you are working for Gmail, you need some way to access all of that email for the person to search it. In our case, what we're going to do in this class is we'll use a pre-made file that contains all the documents. And so gathering them is going to boil down to how to read through this file and parse and extract out each separate document. And that's a standard thing for these collections. They get distributed in these very large files, and it's basically one document after another document after document in one file. And we'll go over the format. All right. So after you gather all the documents, or after you have a document, basically what you end up doing is you take that document and it's time to break it into words. Or perhaps more correctly, to talk about breaking it into tokens, because not all the things that we might chop it up into are truly actually words. And so this process is called tokenization. And you can make the connection to the previous lecture where we were talking about pre-computer information retrieval. And basically, again, a human would take a document and read it and select some words from it and for those to be the index terms. What we're going to do is we're going to take a document and chop it up into all the words automatically using a certain tokenization scheme that's encoded in an algorithm. And all of those words are going to be the index terms for that document. So we're going to do this in an automatic fashion. But that's the next step. Now, then you've got a document. It's broken up into tokens, and we then proceed to use those individual tokens, those individual words, to build an index. All right. The big point of our index is this is designed to, it allows for fast retrieval. You don't strictly need to index things to do information retrieval, but if you want them to happen quickly, you do. If you don't want to have to look at every single document when it comes time to do a retrieval, and your algorithm can support this, you use an index, and it allows you to very quickly compute and find the documents that you think might be useful, might be relevant to the user. All right, we don't want to have to envision, like, you're gathering the documents to the web crawler. This process, fetching all these documents, takes a huge amount of time. Even if you were to read through with a computer all of them, it would take a huge amount of time. This index is a critical data structure, and actually it's a little bit more than just a data structure, but at its core, it is just a data structure. It's very important to be able to enable quick, fast retrieval. Then, once we've got our index built, and then in a live system that is designed to constantly have a flow of documents in, you could actually build the indexing system so that it could continue to add documents to an existing index. In the past, traditionally, what we have done in lots of cases is we gather documents and we build an index. If we want to change any of that collection of documents, we change the collection and then we build a whole new index. But you can design it so that the index can be updated. All right. Next, we move on to the retrieval algorithm. Okay. Basically, we need a mechanism to tell us and help us how to rank. So we're going to put documents in an order, a first document, a second document, and so forth. So rank the documents in response to the query. All right. And then finally, the last stage, really, so the retrieval algorithm is going to be talking and dealing with the index and other components of the search engine. But to talk to the algorithm for the user, we need a good user interface on top of it all. And what's interesting about user interfaces, actually, so we might just think, oh, it's just a user interface. But the user interfaces actually enable better performance of the system, because you can have user interface improvements that help users better satisfy their information needs, or at least faster. And the biggest example of this actually are what are known as query biased snippets. These are what you see when you do a retrieval and you get your list of results, and you've got the title and the small little piece of text. We call that, that has query terms highlighted in it. That's called a snippet. And it dates back to the research when people invented query bias snippets, and they actually found that users who are given query bias snippets are better able to find relevant material, as opposed to users who are only given, let's say, a title of a document. It might seem strange that people didn't know this, but they didn't. And in fact, so this was a very, very impactful research finding. And I think there are lots of ways that user interfaces can actually truly contribute to an overall better system, better performance. All right. So now it is time to look at that search engine architecture. I'm going to put my notes down here. All right, I think actually I'm going to stop the recording and then start it back up so I don't have such a gigantic long recording. Okay.